Hello everyone. Today I'd like to talk about this paper that I really like, Beyond Accuracy, Behavior Testing of NLP Models with a Checklist. So I like this paper so much because it applies the unit testing mindset to do behavioral testing for NLP models. I think the same mindset and framework can be potentially applied to any other models. So in this video, I'm going to talk about this paper briefly and I'll show you how to use checklist package in a Jupyter Notebook. So there are a lot of behavioral testing papers out there. One of the paper, this one is quite interesting, that for question answering tasks used. So here's a question and here's a context. So this paper gives the sentence why, how, because to kill American people at the end of the context, and the model will predict to kill American people for those changed sentence. This is quite disturbing and really concerning to look at. And there are a lot of examples of this. Checklist provides a framework to automatically generate and test those different scenarios and examples to see where our model fails. It tested models along two dimensions. One is capacity, which is a list of tests it can run. Another dimension is testing type, which includes minimum functionality test, invariance test, and directional test. So here are three examples of for sentiment analysis. For minimum functionality test, we generate simple test cases from a template and to see if the model predicts the same as the expected labels. For the invariance test, we do some small data augmentations and expect the labels to stay the same. In this example, we change the location from Chicago to Dallas, and the location change should not change the sentiment of the sentence. And the third case is the directional test. In this example, the author added a negative sentiment sentence at the end of each sentence, and we expect the sentiment to go down, not going up. So what's interesting is that this paper tested all of the state-of-art commercial models. All those models performs human behavior, but when we look at those simple test cases, it has a really high failure rate. The first table is with sentiment analysis. There's another table with the sentence duplications. And then finally, we have this machine comprehension or question answering tasks. We see for this machine comprehension task, in particular, the failure rate is really high. Okay, so how can we? Or another thing. So there are a lot of videos on this papers. So this is one of them. I will link the resources and materials in the description of this video. And then, okay, so how can we use this checklist tool, this checklist package? So this paper is amazing that not only does it have a lot of video tutorials, but also it has a checklist package to help us implement this with our own models. So this is their GitHub page. You can pip install the checklist and the needed Jupyter Notebook extensions. in their notebook section, there are a bunch of notebooks. So I went through some of them, and here for the question answering task, I was checking out this notebook and tried to create a test suite and do some testing. The original code you can find here, but in my example, I changed the data, also the model, and some other small functions to be able to run my example smoothly. And I will link all my notebooks in the descriptions below so you can take a look. Okay, so how does this actually work? Well, we need to first of all import all the needed packages and modules. And here I'm using a Hugging Face model. This is how Hugging Face works. We give it a transformers pipeline, calling a question answering model. If we don't provide this model, it will default us to this model and load this model. And then I'll give it a context and question. This model will give us an answer with a confidence score. If you have your own model, you can load your model directly. In this case, I have a trained model. We can load the model and the token from this trained model. You can see it give us the same answer with a little better confidence score. Okay, now coming to Hugging Face. Hugging Face has this large, I guess, word bank that will give us a list of named entities or things, I guess, or words. For example, it will give us a list of first names, last names, locations, whatever. But for things that CheckList doesn't provide, we can use editor.suggest function and using this mask tag. And then CheckList will use a Roberta model to help us automatically generate those adjectives we need. Okay, so with all those words, we can use the editor.template function to automatically generate examples for our testing cases. Yeah, for example, here we generated an example of Alice is richer than Joseph. The question is, who is richer? And we expect the label to be Alice, but the model predicted Joseph. So likely in this example, the failure rate is fairly low, only 3%. So our model is able to understand this context and this question and then give us the correct answer, basically. However, if we change the question to who is less something, then all of a sudden the failure rate increased to 99%. That means our model cannot understand those sentences. So this first example is with the minimum functionality test, MFT. The second type of test is the invariance test. In this example, we give our question a typo, so this question becomes this part of is a typo basically, and then we expect this invariance function expect the prediction between those two questions to be the same, and in this case the predictions are not the same, so it's one of the failure cases. The failure rate in this case is 17%. Another interesting thing I want to show you is that CheckList can be a tool to test fairness. See if a model have any of the gender bias, racial bias, and so on. This example tested gender bias. Generates examples of male, female is not a profession, female, male is, so who is this profession? So this is the name of the female, name of the male. And then we see if the failure rate between male and female are different or similar across different professions. Okay, so this notebook has a lot of test cases, as you can see here. One of the things that the author did was that we were able to save all those test cases, add them to a test suite, and save those to a pickle file. So in another notebook, as I'm showing here, that we can just simply load the model, load the test suite, and run this test suite for all the tests. And then it provides a nice summary for all the tests, and we can visualize this summary really nicely. Here are the two examples we were just talking about. One is 0%, one is 100%. And then we can see the failure examples here. It's quite nice, and then we can see the question typos with the examples. We also have like all the different examples. We added a random sentence to the context, and we see 10% of the time the model can produce the same result. So this is how CheckList works. We generate tests automatically based on the templates, or we're doing various tests, and we create a test suite, save to a pickle file, and then we can run the test suite all together and visualize the results. It's all great. And then I was wondering, what if we train our model based on those test cases? So I actually combined the Stanford question answering data set and all the test cases from my test suite. And then I ran the test on the same test suite, but with different words and adjectives and all that. And surprisingly, the failure rate dropped to 0%. This means the model can be trained quite easily if we find the issues of the model. But finding the issue can be tricky and hard. This is where CheckList provides values to help guide and help improve the model, guide the researchers to find where the problems are. So yeah, I will link all the notebooks in the description, so you can test it out. And I encourage you to check out this paper and also the repository of this paper. This is quite amazing. I really like this paper. Hope you enjoy it. Thank you.